Kubernetes and GKE Part 44. This episode has 20 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Scenario: A secret was accidentally committed to Git. What should you do? Here's a strong way to approach it. Immediately revoke and rotate the secret, then assess where it was used and whether it was accessed. Remove it from active branches and history where appropriate, but rotation is the urgent control because Git history may already be copied. Add secret scanning and pre-commit or CI checks to prevent recurrence. Nice. Let's continue. Question 2. How do you implement GitOps for Kubernetes? Here's a strong way to approach it. Store desired Kubernetes manifests or Helm or customize configuration in Git and use a controller such as Argo CD or Flux to reconcile clusters to that state. Changes go through pull requests, review, policy checks, and automated sync. Git becomes the audit trail and rollback mechanism for cluster configuration. Great. Moving on. Question 3. Scenario: Argo CD shows out of sync but applying manually works. What could be wrong? Here's a strong way to approach it. Check generated manifests, Helm values, customize overlays, ignore differences, admission webhooks, resource defaults, and fields mutated by controllers. Manual apply may use different inputs than Argo CD. The fix is to make Git match the real desired state or configure diff behavior for known controller managed fields. Alright, next question. Question 4. What is the role of admission controllers in Kubernetes? Here's a strong way to approach it. Admission controllers validate or mutate API requests before objects are persisted. They can enforce security, defaults, quotas, image policies, labels, and compliance rules. Examples include pod security admission, validating webhooks, mutating webhooks, and policy engines. Let's keep going. Question 5. Scenario: A new policy blocks deployments in production. How do you handle it? Here's a strong way to approach it. Identify the exact policy violation and determine whether the workload or policy is wrong. If the policy is valid, fix manifests and update templates so future deployments comply. If the policy caused an unintended outage risk, use a controlled exception process with time-bound approval and follow-up remediation. On to the next one. Question 6. How do you design IAM and GCP for least privilege? Here's a strong way to approach it. Grant roles at the smallest practical scope, prefer predefined or custom roles over broad owner or editor roles, and use service accounts per workload. Avoid long-lived keys by using workload identity federation, or short-lived credentials. Review IAM regularly and monitor audit logs for suspicious access. Good. Here's another one. Question 7. Scenario: A service account has owner role in production. What is your remediation plan? Here's a strong way to approach it. First, identify what permissions the workload actually uses through logs, policy analysis, and documentation. Replace owner with least privilege roles. Test in lower environments, then roll out with monitoring. Add guardrails such as organization policy, IAM review, and CI checks to prevent broad roles from returning. Nice. Let's continue. Question 8. What are Terraform provider version constraints? Here's a strong way to approach it. Provider version constraints control which provider versions Terraform may install. Pinning versions prevents unexpected behavior from provider changes. Teams should use log files, review upgrades deliberately, and test module compatibility before applying to production. Great. Moving on. Question 9. Scenario: A Terraform provider upgrade changes many resources. What should you do? Here's a strong way to approach it. Read the provider changelog, inspect the plan carefully, and test in a non-production environment first. Separate provider upgrades from feature changes to reduce risk. Use state migrations, moved blocks, or module updates where needed, and avoid applying large unclear plans. Alright, next question. Question 10. How do you test Terraform code? Here's a strong way to approach it. Use Terraform FMT, Terraform Validate, static analysis, policy checks, module unit tests, and integration tests in temporary environments where practical. Also review plans in CI before apply. Testing should catch syntax errors, security issues, naming mistakes, and destructive changes. Let's keep going. Question 11. Scenario. Terraform state lock is stuck. How do you resolve it? Here's a strong way to approach it. First, confirm no apply is currently running. Then inspect who holds the lock and why it is stuck. Only after verifying it is safe, release the lock using the backend supported mechanism. Then rerun plan to ensure state is consistent. On to the next one. Question 12. How do you build a Python tool to clean old GCP resources safely? Here's a strong way to approach it. List candidate resources with filters, labels, age, and ownership metadata, then run in dry run mode by default. Add allow lists, confirmations, audit logs, retries, and deletion batching. For production safety, require labels and approvals before deleting anything. Good. Here's another one. Question 13. Scenario. A cleanup script deleted a needed resource. How do you prevent recurrence? Here's a strong way to approach it. Restore from backup or recreate the resource first, then perform root cause analysis. Add dry run defaults, deletion protection, label validation, allow lists, tests, peer review, and staged rollout. High-risk cleanup should have clear ownership and audit trails. Nice. Let's continue. Question 14. How do you parse large log files efficiently in Python? Here's a strong way to approach it. Stream the file line by line instead of loading it fully into memory. Use generators, compiled regular expressions where needed, and structured parsers for JSON logs. For very large datasets, consider tools such as BigQuery, Dataflow, or distributed processing instead of a single script. Great. Moving on. Question 15. Scenario. A Python service has high memory usage in Kubernetes. What would you check? Here's a strong way to approach it. Check object growth, caches, batch sizes, worker count, memory leaks, dependency behavior, and whether requests or limits match actual usage. Use profiling tools, heap snapshots, metrics, and container OOM events. Fixes may include streaming data, limiting concurrency, clearing caches, or increasing memory only after understanding the cause. Alright, next question. Question 16. What is async programming in Python useful for? Here's a strong way to approach it. Async programming is useful for I or O bound work such as API calls, network operations, and concurrent waiting. It can improve throughput without creating many threads. It does not automatically speed up CPU-bound work, where multiprocessing or optimized libraries may be better. Let's keep going. Question 17. Scenario. An API automation tool is slow because it calls 500 endpoints sequentially. How would you improve it? Here's a strong way to approach it. Use controlled concurrency with async I or O or a thread pool, while respecting rate limits and retries. Add batching or caching if the API supports it. Measure before and after so the improvement is real and does not overload the dependency. On to the next one. Question 18. How do you approach incident response for cloud-native systems? Here's a strong way to approach it. Start with impact assessment and mitigation, then investigate using metrics, logs, traces, recent changes, and dependency health. Communicate status clearly, escalate when needed, and keep a timeline. After recovery, run a blameless review and convert findings into preventive actions. Good. Here's another one. Question 19. Scenario. Latency increases after moving to a new GCP region. What do you check? Here's a strong way to approach it. Check user location, load balancer routing, database location, cross-region calls, egress paths, DNS, CDN or cache behavior, and dependency regions. Latency often comes from hidden cross-region dependencies. Fix by collocating services and data, using global load balancing correctly, or redesigning for regional locality. Nice. Let's continue. Question 20. How do you design disaster recovery for GCP workloads? Here's a strong way to approach it. Define RTO and RPO first, then choose backup, replication, failover, and restore strategies based on business needs. Test recovery regularly instead of only documenting it. Include application state, databases, secrets, DNS, IAM, infrastructure code, and operational runbooks. Great, moving on. That wraps up this episode. Nice work practicing, and see you in the next one.